BA. So we're starting at the point B. We're going to move to O, and then we're going to move to A. So BA equals BO plus OA. Now I hope you can see that moving from B to O we go against the arrows. So it's minus 2B. But when we move from O to A we're going with the arrow. And I'll turn that round and write it as A minus 2B. MQ. MQ, we're going from this point here to B and then to Q. So MB plus BQ. Now, I hope you can see that BQ, this part here, BQ is 1/3. BQ is 1/3 of BA. So this distance here is 1/3 of the whole distance, because we're told that these three are equal in length. Okay, so MB is fine, that's B, we're going with the arrow. We've just worked out what BA was, it's A minus 2B. So we've got B plus 1/3 of A when we expand the brackets, minus 2/3 B, 1/3 A plus 1/3 B. And the last thing we have to do is OP. Now, OP is a bit tricky as well. So what are we going to do? Well, we're going to go from O to A, and then from A to P. So OA plus so equals OA plus AP. Now OA is fine. AP, I hope you can see, AP is 1/3 of AB. Now, AB is the same as minus BA. Why am I changing it? Because we've already got BA here. So we can rewrite that as OA minus 1/3 BA. OA is A minus 1/3 A minus 2B, and if you expand the brackets carefully you'll get 2/3 A plus 2/3 B. This is the sine rule. Why do we know it's the sine rule? Because we have a side angle pairing. That's very important. So A over sine A equals B over sine B. 8 over, let's have x over sine 35 equals 8 over sine 55. I'm going to multiply by sine 35 to get rid of the dividing sine 35, which is underneath the x, so x equals 8 over sine 55 multiplied by sine 35. Put that into your calculator and you get the answer 5.60 centimetres. This second example is another question where we're going to use the sine rule because we have a side angle pairing. So A over sine A equals B over sine B. In this case we're trying to calculate the missing angle, so we've got 7 over sine x equals 10 over sine 80. In this type of problem we have to cross multiply, so 10 sine x equals 7 sine 80, and we'll divide by sine, beg your pardon, we'll divide by 10 to get sine x on its own. So we can use the calculator again, but this time it will have to be shift sine. Make sure your calculator is on degrees. Check the calculator screen, and if there's a D on it, it means you're in degree mode. 43.6 degrees is the answer. We don't have a side angle pairing, so it's got to be the cosine rule, and it's a missing side. So the formula we use is a squared equals b squared plus c squared minus 2bc cos a. It doesn't matter whether we have the 8 first or the 9 first, it doesn't matter at all. 2 times 8 times 9 and the cos of 72 degrees. You can put that straight into your calculator if you want. As long as you're careful, you'll get the correct answer. Now it's important that you do this part together. Now would be a good time to put it straight into the calculator, but I'm going to do one more line of working. And don't forget to take the square root at the very end. Another problem involving the cosine rule for a side. We don't have a side angle pairing. Always write down the formula. So again, it doesn't matter the 2.1 goes in first position or second position. 2.1 squared plus 4.1 squared minus 2 times 2.1 times 4.1 cos of 110 degrees. .41 16.81 17.22 cos of 110 degrees. 21.22 minus. Now, when you do this on the calculator, because this angle is bigger than 90 degrees, you're going to get a negative value. Don't be alarmed by that. So 17.22 times cos of 110 is negative 5.89. Gives us a total of 27.1011, and if we take the square root, we get the answer 5.2. I've just realised that the answer should be given correct to three significant figures, so let me just erase that. And it's so it's on the calculator 5.2067, and we want three significant figures, so that 67 is going to round up and give us 5.21 centimetres. This is an example of the cosine rule for an angle. We have three sides and no angle, very distinctive setup. Now, the formula is b squared plus c squared minus a squared over 2bc. It is very important that the side opposite the desired angle goes in this position here, so that 11 must go in last position, can't go anywhere else. 7 squared plus 10 squared minus 11 squared over 2 times 7 times 10. Since we're trying to find the angle, shift cos we get 78.463 degrees, and since we want the answer correct to three significant figures, the 63 is going to round up to make it 78.5 degrees. So this is a problem about depreciation. If you think about the original value of the car as being on 100%, and it depreciates in value by 15% a year, which means that 85% of its original value is left. As a decimal, 85% is 0.85. That's going to be the decimal multiplier in our problem. So we've got a car which is originally worth £15,700. Use the decimal multiplier to indicate the depreciation each year, and the 3 for the 3 years is going to go in this position here. The answer we get is 9641.76. Indices: x to the power of 4 multiplying x to the power of minus 2. The rule is that when you're multiplying, you add the two indices together. So we have x to the power of 4 plus minus 2, and that's x to the power of 2. Y to the power of 5 divided by y to the power of minus 2. When dividing, we subtract the two indices, so it's y to the power of 5 minus minus 2, which gives us y to the power of 7. T to the power of 4, all cubed. Now in this instance, when we have a power raised to a power, we multiply the two indices. So it's t to the power of 4 times 3 and t to the power of 12. Part G, we've got a bracket 4x cubed b squared all squared. Now, what could we do? Well, the square axe on the 4. 4 squared is 16. What we have then is we've got an x cubed and the b squared squared. So what we can do is we'll multiply the 3 and the 2 to give us x to the power of 6, and we'll then multiply the 2 and the 2 to give us b to the power of 4. 17a, we've got triangular prism here. The first thing I'm going to do is to work out the area of the shaded part at the top. That's a right angled triangle, so the formula is a half of the base times the height. Now, it's a half of the base times the height of the triangle. The base of the triangle is 5 and the height is 8, or vice versa, but it's those two numbers that we use. So it's a half of 8 times 5. 8 times 5 is 40, divided by 2 is 20 centimetres squared. The formula for the volume of a prism is area times height. We know that the area is 20, and this time it's the height of the prism that we're interested in. So it's 20 times 11, which is 220 centimetres cubed. The formula for what we have here is a cylinder. The volume is, we could use the same volume formula that we used in part A, area times height, but this time the area is the area of a circle. This here is a circle of radius 5, so it's pi times 5 squared times a height of 13, and the answer is 1021 centimetres cubed. This is part C is a cone. 1/3 of the area of the base times the height, so it's similar to the formula that we used in part B, but not the same. Pi r squared h. Now be careful, the radius of the circular base is 6, 1/2 of 12. The answer we get is 377 centimetres cubed. What we have here is a hemisphere. The volume of a sphere is 4/3 pi r cubed. We can use that just now. That gives us 214.66 centimetres cubed, and since it's a hemisphere we'll divide by 2 and get the answer 1072.3. Now, just realised that we should be giving the answers correct, 3 significant figures. So in this case, there are the first 3 relevant numbers. 2.33 will round down. Now, first of the circle questions. What we have to understand is that this line here is a tangent, and a tangent meets the radius of a circle at 90 degrees. So this angle here is a 90-degree angle. Now, that means that these two angles must add up to 90 degrees. The 3 angles in a triangle add up to 180. We know that this one here is 90. What do I add on to 35 to get 90? I get 55 degrees. Now, next thing, this angle here is a straight angle. 180 degrees. What do I add on to 55 then to get 180 degrees? I add on 135 degrees, which is the desired answer. Now, we know that this is 48 degrees. This here is a tangent, so this angle is 90 degrees. This line is a tangent as well, so this angle here, the angle which the tangent makes with the radius, is also 90 degrees. What we have is that's a tangent kite. Now, those two are 90. What we have to do then is this one here plus the 48 add up to 180. 180 take away 48 is 132 degrees. So 132 degrees. Now, I hope you can see that this triangle here is an isosceles triangle. These two lines that I've just marked are radii. They start at the centre of the circle and they move to the circumference. So those two lines are the same length. The triangle is isosceles, so the two angles must be the same. 180 take away 132 degrees divided by 2. So that's 48 divided by 2, and we get 24 degrees each. We have a triangle drawn inside a semicircle, which means that this angle here is a 90 degree angle. We are told that this angle here is 52 degrees. That's this angle. What we have to remember, of course, is that this is a tangent, so this angle is a 90 degree angle. Now we know that the first part is 52 degrees, so the second part will be 38. Inside the triangle, the three angles add up to 180 degrees. We know that this one here is 90, so the other two must add up to 90 as well. 38 from 90 gives us 52 degrees.